All right, let's go over this one. So to do this one, we graph this line, and you can solve it for y, or you can use quick graphing. Let's practice both. Make sure that you can find x-intercepts, y-intercepts, and the slope. Plug in a 0 for y, and you can get 2x equals 6, so x equals 3. Plug in a 0 for x and solve for y, and you get y equals negative 6. The slope appears to be up 6 over 3, which would be a slope of 2. Let's check. If you move this over to the other side, it becomes a negative 2x. Then you would divide by a negative 1. A negative 2 divided by a negative 1 is 2. So we must have a slope of 2. So there I've graphed the first line. Remember, all of these points on the blue line are solutions to this equation. We'll graph all the solutions to the second equation. That is in slope-intercept form. The negative 8 doesn't really fit. You can count down a couple if you want, but I think it's just going to be a lot easier if we just find another point. So let's let x equal, 2. So when I plug that in, 4 times 2 minus 8, I get y equals 0. So that tells me that's on there. Now I'll use my slope of up 4 over 1. I'll also go down 4 over 1. So that's just kind of whenever you have a y-intercept that doesn't fit on your graph, you can either, extend down if you really want to, but simply use your slope and get another point and start from there. All right, it appears as if these two lines intersect at the point 1, negative 4. So that's a solution on both lines. Let's check. That's 2 plus 4. That equals 6. All right, let's try the second equation. It says y, which is negative 4, has to equal 4 times x, which is 1. So that's negative 4 equals 4 minus 8, and that's true as well. So that's the solution to the system of equations. All right, would you please practice 5.2? Okay, let's go over our second practice problem. We're going to solve this using the substitution technique. You may be at a point where you prefer elimination, but we need to be sure to do both because the substitution technique is important in its own right. So I want to get one of these equations solved for a letter, and I need to pick the easiest one to solve for. So if I solve for this x, I'd have to divide by 3. If I solve for that y, I'd have to divide by negative 2. If I solve for this y, I have to divide by 5. So clearly, solving the bottom equation for this x is the only one where I don't have to divide. And I don't want to divide because dividing causes fractions, right? Okay. So if at all avoidable, we want to avoid it. Sometimes you can't. So I move the 5y to the right, making it a negative 5y. I'm now going to take that. That's what x is equal to, and I'm going to replace it in the other equation's x. And when I do so, I'll make sure to put it in parentheses. Like so. Okay, so now after doing the substitution, I have an equation that I can solve because it's one equation with only one unknown. One letter, that is. So that's a negative 15y when I distribute minus 60 minus 2y is equal to 8. That makes negative 17y. And add 60 and I get 68. And I don't know, I'm just going to bet that I chose a whole number here. So I think that that's 4. Isn't it negative 4? Yeah. If you just check the multiplication, 17 times 4, 28. 4 plus, yeah, so definitely. All right, so we got y is equal to 4, and the one nice thing about substitution is that you have an equation ready to plug in and tell you the other variables. So we'll just go right to that. That becomes 20 minus 20, which is 0. So we think 0, negative 4 is the solution. We want to check, though, so let's check in the first equation. So 3 times 0 minus 2 times a negative 4, does that equal 8? Well, that's 0, and then minus a negative is plus a positive, so I'm going to say that works. And we'll try the bottom one. 0 plus 5 times a negative 4 equals negative 20. That's also true. That's 0. That's a negative 20. So, yeah. So we did it. All right. Please try the next practice problem. Okay, let's go over practice 5.3. What shall I get rid of? I'll do x's. I'm going to multiply the top equation by 4. And I'm just going to write it like that. That's not really like mathematically correct. I should put parentheses on both sides, but it gets the point across. Okay, so the top equation, I'm multiplying each thing by 4. The bottom equation, each thing by 3. So, 12. And when I add them, the x's cancel, and I end up with a negative y is equal to 96. So y is equal to negative 96. Okay, now I need to find x, which is not really going to be particularly fun with the size of this number. But we can do it. So 96 times 2 is 192. So this is a negative 3x minus 192 equals 6. So a negative 3x is equal to, when I add 192 over, I get 198. Now I know that this is divisible by 3 because if you add all the digits, the sum of the digits is divisible by 3. 18 is divisible by 3. So that's good news. So our answer, before I forget, I'm going to put my negative down. 3 goes into 18 6 times, so... Is that right? 66? Well, all right. Now, these numbers are kind of large, so I'm going to check it probably with a calculator. And with the calculator, it tells me it worked. So I'm going to call it good. It's good to have good big numbers sometimes to have to deal with because that's real life. But, for now, we'll just assume that's right. Okay, practice 5.4. Okay, here we go. Practice 5.4. We could use substitution. We could also eliminate x's or z's. But I think the easiest thing to do is to eliminate y's. So I'm going to add the top two equations together, which will give me 2x plus z equals 7. Then I'm going to add the top and the bottom equation together because the y's will cancel as well. And I'll get 3x, y's cancel, minus z equals negative 2. I'll then solve the resulting system of equations of two variables. I'll add the two together, and I get 5x equals 5. So x equals 1. Now that I know what x is, let's find what z is. I'll use 2x plus z equals 7. So 2 times 1 plus z equals 7. So z equals 5. Now that I know what z is, let's find what y is. I'll use the middle equation, which is x plus y minus z equals 3. So 1 plus y minus 5. That makes negative 4. So I get y equals 7. So my solution is 1, 7, and 5. Let's check. On the top equation, 1 minus 7 is a negative 6, plus 10 is 4. 1 plus 7 is 8, minus 5 is 3. 2 plus 7 is 9, minus 15 is negative 6. So it works. All right. Let's do one more practice problem. Okay, so this one here is set up for substitution really well. So I'm going to replace x in the top equation with 4 minus z. And then when I distribute, I get 8 minus 2z minus y plus z equals 10. So that becomes 8. Negative 2z plus z is a negative 1z, but I'm going to keep them in alphabetical order here. Then I'll subtract the 8. All right, now this other equation is y minus z equals 6 from up here. And I can solve that resulting system very easily by adding the two equations, and I get negative 2z equals 8, so z equals negative 4. Now that I know that z equals negative 4, I'll plug it into this y minus z equals 6. So I get y minus a negative 4 equals 6, so y plus 4 equals 6, so y must equal 2. So now I know that z is negative 4, I know y is 2. Let's find out what x is using this top equation right here. X is equal to 4 minus z. Z was a negative 4. So x must equal 8. So we think our ordered triple is 8, 2, negative 4. Let's double check our work. That would be 16 minus 2 is 14, and 14 minus 4 is 10. This says 8 equals 4 minus a negative 4. That's true. 2 minus a negative 4 is 6. And that's true. So they all worked. And that's it, except for the exit ticket.